Okay, now look over here. So this is lecture 4, and again we'll start with some numerical, last phase of the numerical, which are one of the two best numericals ever. Okay, after that we'll jump to Lenz law and motional EMI, right or not? Okay, so let's start solving it. Question number 1, based upon that illustration 5. Till now we have done all the 4 illustrations. This is illustration number 5. Do it. What is saying? You have some kind of flexible circular loop of 10 centimeter in diameter. Okay, this circular loop is flexible, and how much diameter it has? 10 centimeter in the magnetic field of 1.2 tesla, directed into the plane of diagram. The loop is pulled at the points indicated by the arrows, right or not? Means we are pulling this loop. If we pull this loop, what will happen? The circle will start changing into the circle will start changing into oval or oval shaped or not? Tell me yes or no. Now the question is, the loop is pulled at the points indicated by arrows, forming a loop of zero area in 0.2 seconds. Now if the loop is formed with zero area in 0.2 seconds, that means what? It is forming a straight wire, right or not? If a circle is flexible, have you seen a rubber band or not? If it is flexible, if it is in normal shape, it will be in a perfect circle. But if it stretches from both the points, does it become a straight wire or not? Tell me yes or no. So that's what it is saying. The loop is becoming of zero area in 0.2 second. Find the average induced EMF in the circuit. What is the direction of R? What is the direction of current in R? And what amount of charge flow through this R if this during this time if R is equal to 10 ohms. Wait fast. Do you want to switch off the slides? No. Tell me. How to solve this question? Right, tell me, Baba, what is happening? Over here, initial area was what? It is the area of circle. Or yes or no? Initial area is what? Area of circle, which is equal to pi r square. Pi diameter is 10 centimeter. R will be what? 5. So 5 by 100 square. Right or not? What is your final area? 0. Yes or no? What is your final area? 0. So flux, can you get over here flux initial? That is going to be what? B dot dA, which is going to be what? B dot A. Actually, now look over here. The normal of the particular circle and the particular like magnetic field will make 180 degree with itself or not? Tell me yes or no. Or you can consider even 0 degree, because we can draw normals to the down also. So therefore, flux will be how much? B into pi r square. B is how much? 1.2 Tesla. 1.2 into pi into 5 by 100 square, right or not? Now flux final will be equal to 0 or not? Why? Because area is getting 0. So EMF is what? Minus of d phi by dt or not? Tell me yes or no. So minus of d phi is going to be what? Minus of, this is going to be finite, so flux final minus flux initial divided by time taken. So what is your, can you solve this question or not? After that, flux final is 0, flux initial is how much? Pi r square into magnetic field, this term, and time is also given. See, the loop, the area of the loop changes in how much seconds? 0.2 seconds. Right or not? Yes or no? Do it fast. Hey. Second question is, what amount of charge will flow through this R during this time if R is equal to how much ohms? 10 ohms. So can you calculate the first current established over here, which is going to be what? EMF by R, right or not? So that is what my total current established over here. Now this current is going to be also equal to what? Charge Q by time taken or not? Tell me yes or no. So can you say that Q is equal to nothing but EMF by R into time t. Got it or not? What is your EMF? You will get over here resistance, which is given 10 ohms. Time is how much seconds? In how much second it is getting pulled? 0.2 seconds or not? So Q is equal to EMF by R into 0.2 seconds. So current is established only for only there for how much seconds? 0.2 seconds. So therefore Q will be equal to EMF by R into 0.2 seconds. Got it or not? Okay, I'm changing this question. You'll have to solve it. Got it or not? Is it okay? Done? Solve that dV by today itself. And paper number 13 and 12. Tell me. Tell me who will submit? When? Today is what? 11th. Hmm? When you guys are going to submit? Paper number 13 and 11? Huh? Two papers are also not done and half of the month is over. Half of the month is over. Little bit get away from your sleeping schedule, what you are following. Sleep for 3 hours or maximum 4 hours. Listen to me perfectly. This way, do you think that here it is not that visible? It's not visible. Where I have prepared, it's visible. We didn't used to sleep for more than 4 hours in ever in my life. When I was a student, I have never slept more than 4 hours. If it was required, I used to wake up for 3 days. This NEET J, listen, this NEET J is not a cup of tea. It's not a cup of tea. The syllabus is that much vast. You have to understand that your life depends on it. If you make it as a life, then only it's possible that you will work hard. Last 6 months are left, not even 6 months. You will be busy for 3 months in the boards, but I'll suggest you to prepare for NEET during that time. At least revise first few syllabus. Okay, boards is also necessary. I'm not saying, but reading 8 hours for board, giving only 3 hours for NEET will be enough. How much hours do you need during those times? November, December dates are out already. In May, they are going to take the exam, first week or second week. Your board exams and NEET exams dates are also out. December 23, they will start filling up in December, they will start the registration. Yesterday it was announced, JEE Mains, NEET and all, CUET, all the dates are announced. So in your May, you will have your exams. So after your board exams, I have seen that this board exams, what is the biggest point of CBSE? They take the board exams within 15 days, complete it fast, and they will complete in February. They will get direct 2 months for the preparation of NEET exams or JEE exams. You are going to get maximum 30 days. Your exam starts from 10th, ends on 24 or something like that. 28. 20 days big gap. And after that, how many days are there for your NEET exam? Only 1 month, maximum 1 month. Because in May, definitely the upcoming Sunday of May will be your exam. Make a plan, something like that. Do not think it is an easy thing. Okay, solve the next question. Question number 2. What it is saying? The magnetic flux through a stationary loop with resistance R varies with time interval tau. Okay, look over here. What it is saying? The magnetic flux through a stationary loop with a resistance R varies during the time interval tau as phi is equal to 80 tau minus t. Find the amount of heat generated in the loop during that time. The inductance of loop is to be neglected. Do it fast. Flux is given over here. What is given for the flux? Flux is equal to AT tau minus T. Now look over here. See the terms over here. A is a constant term. Yes or no? T is what? This is actually time variable. Remember that. Not tau. Time variable is what? T. And tau is what? It is a fixed quantity. What it is saying? You have the magnetic flux for the resistance R during the time interval tau. Time interval means what? A fixed time interval or not? Tell me yes or no? So therefore, which is your fixed variable? Tau is fixed variable. A is fixed variable. Which is a variable quantity? Small t is your variable quantity. Now, you know EMF is equal to what? Minus of d phi by dt. Right or not? So this will become what? Minus of a into tau minus t. I am writing directly. Plus what will come next? It will be a t into minus 1. Yes or no? So the terms will be like this way. I am writing it directly. A tau minus t into minus of at. Right or not? Chain rule I will apply. Yes or no? Two products are there. Chain rule I am definitely going to apply. So what you get over here? Minus of a tau minus of 80 minus of 80. What you got as answer? 280 plus of, sorry, 280 minus of a tau as your EMF. Void or not? Or yes or no? So now look over here. What will be current? It will be EMF by resistance R or not? What will be current at that time? Tell me. Uh-huh. What will be that? It will be A common 2t minus tau divided by resistance R. Yes or no? Yes or no? This is going to be your total value of current or not? Now, this current is actually time variable or not? Tell me yes or no? So, if current is also time variable, total heat generated is asking. What is the amount it is asking? It is not asking the heat at that instant. What it is asking? Total amount of heat. So, it will be from, there will be integration or not? Yes or no? You have the formula of particular heat as what? I square R into dt. Got or not? Now, this integration will happen from where to where? For what time? During that time it is asking, that time means what? Which time it is asking? It is asking for interval tau. So 0 to tau. Got it or not? So now look over here. Can you solve this integration? Do this fast. Hi Anurag Misra. Thank you for accepting the offer letter for the position of assistant professor in physics Palla Vidyapeeth Academy, Chandigarh. Yes, but for next year. 17. Go ahead, Rose, do not tell to anyone, otherwise I'll kill you. Or not. Not tell to anyone. Thanos, is it okay to go on? Hey, do this question. It's good, yeah, kind of. A square. Now, can you solve this question or not? Did you have solved this kind of questions? Huh? This kind of integrals. What you are going to do? Direct, like, can you solve it directly? Substitution. There is nothing like substitution in these kind of questions. You can solve it directly. Think. Okay, so I'm directly telling you the answer. Okay, after solving this integration, the answer will come as 4a square tau cube. Okay, divided by 3r. This is going to be your net answer of this particular heat, and it is going to be in joules, right or not? So this is your total heat generated during this particular time from 0 to tau. Is that clear? Yes or no? Is this clear or not? Okay. Now, can I move ahead? Now give the heading Lenz law, right or not? Now, this Lenz law, this whole of this Lenz law, we are going to do in a different way. Right or not? Yes or no? You have you heard about, like, in Lenz law you have only taken, I think, 2 points. I think only in your boards only two things would have been done. Yes or no? Like if the magnet enters the coil or if the magnet get outside of the coil. Right or not? But Lenz law is not restricted to that only. It's a combination of all. It's a big combination actually. So now look over here. The first law is what? So let us consider that you have some kind of conducting loop. What you have? You have some kind of conducting loop. That conducting loop is getting pulled inside the particular magnetic field. Which kind of magnetic field you have? You have a outside coming magnetic field. See, dot means what? Outside. Actually, it's just opposite of what we were taking. And cross means what? Inside. Means this is getting followed in many books, so we'll follow this one, right or not? But mind convention, which I used to use earlier, it's actually given in HCBOM, right or not? These are the basically basic, many of the books follow, so that's why we are going to follow this on, right or not? So now look over here. Let's suppose you have some kind of conducting loop. What kind of conducting loop? Closed conducting loop. What kind of conducting loop? Closed. Remember that EMI only acts on closed conducting loop. The current will be generated on only closed conducting loop. If it is not closed conducting loop, there will be no current, zero current, right or not? So you have a closed conducting loop that is getting pulled inside the magnetic field. Now, if it is getting pulled inside the magnetic field, tell me one thing: is the total area of this current, means total area of this loop, is getting increased in this magnetic field or not? Tell me, Saurav. Outside, the total area in this magnetic field is how much? 0. Now, it is a full square, A square. Yes or no? If the side of the square loop is how much? A over there. Is I am correct or not? The nose. So it is straight. So now look over here. Here area is what? 0. Here area is finite. So if area changes from 0 to finite, what is going to happen? Flux will be produced. Yes or no? If flux is getting produced, now look over here. Is this flux is changing with respect to time? Is this flux is changing with respect to time or not? Sure. Why it is changing? Because try to understand, when the loop is entering inside the magnetic field, what is happening? When this particular loop is entering inside this magnetic field with velocity v, first some of the area will come like this way, yes or no? After that, some more area will come inside it. After that, some more area will come inside this. So that means what? Area is changing with respect to time or not? Tell me yes or no. If area changes with respect to time, then what will happen? Flux will also change with respect to time. If flux changes with respect to time, what will be generated? EMF will be generated. But the question is, if that EMF is generated, it will produce some kind of current or not. Let's suppose this loop has some kind of resistance R. Remember that. If the loop does not have resistance, then there will be zero current. How much will be the current? Zero. Remember that, right or not? If the loop has resistance, then only it will generate the current, because the law of conservation of energy should be there. Law of conservation of power should be there, right or not? You are applying some power, that power should be absorbed definitely. If that power is absorbed, then only what will be produced? Current will be generated, right or not? Or yes or no? So now look, if the loop has a resistance R entering into this magnetic field, now flux is changing. Look over there. In this case, is the flux is increasing or not? What is happening, guys? Look over there. Try to understand. Initially, the flux of the system was how much? 0. Or yes or no? because there was no magnetic field lines crossing through this particular area. Yes or no? So flux is how much? Zero initially. Now, when it has started entering into the magnetic field, the flux has suddenly started increasing or not, because the area inside the magnetic field is also getting started. So what is happening? With respect to time, what is increasing? Flux is increasing. Got it or not? Or yes or no? So, okay, first write this line. Can you move ahead? Now, wait. One thing, try to understand. Now, Lenz told something about this. Lenz thought, like Lenz told something related to this. What he told? Hey, close that door. Yeah. You have studied this now. Let's suppose you have a circular coil. Let's suppose if you have a circular coil and there is a bar magnet over here, north pole over here, south pole over here. So if it starts to come towards this side with velocity v, Lenz, what does he visualize? That in this also, what kind of current was getting produced? Actually, anti-clockwise current was getting produced if this magnet starts to come towards this side. So the reason was what? Lenz thought what should be the reason. So actually he told that all of this loop follow law of conservation of energy. If law of conservation of energy is there, that means what? Initial energy should be equal to final energy. Are yes or no? Initial energy should be equal to what? Final energy. If initial energy is equal to final energy is there, that means what? No work should be done on the particle or no work should be done on the loop. Yes or no? So if no work is a condition, that means what? Total force on the system should be how much? Zero. If external should be how much? Zero. If external is zero, how I'll see that? So look over here, if this magnet is coming towards this side, it is going to particularly increase the flux over here in this loop or not? Tell me yes or no? And it will do some work on the loop or not? Yes or no? To conserve this means to make work done to be equal to zero over here in this loop. What should happen? This particular loop should generate something. This loop should generate something which should actually oppose this particular movement of magnetic movement of this bar magnet towards the loop or not? Tell me yes or no? Or yes or no? And for that only, what it generates, it thoughts that okay, let us generate some kind of north pole over here. What it generates? North pole. If I generate the north pole, what will happen? Due to this north of this magnetic field, what will happen? Some kind of anti-clockwise current will develop over here, and it will preserve the fact. See, if this is north pole, this is north pole, what will happen? Repulsion will happen or not? And due to that, what will happen? The bar magnet will do not try to go through this circular coil. Got it or not? But this generation of the north pole has induced some current on the circular wire, yes or no? Or the closed, got or not? So this was the total prediction of Lenz law. What he told that every coil or every system, every closed loop is going to oppose any changes in it, any change changes in their system. So what it is going to, what is the property of the closed loop? That it will oppose any kind of change in its system, right or not? Any kind of change means what? Like let's suppose if this particular bar magnet has came over here now, so this is north pole, this is south pole. Now when it is coming over here, what has happened? Some kind of current has been generated over here, yes or no? When it is going out, what is happening? This is my south pole or not? Tell me yes or no. When it is going out, what is happening now? This particular magnetic, this particular circular loop, since it has, let's suppose, try to understand, if you have eaten good food and suddenly you get a loose motion, how much bad you will feel? Suddenly how much bad I will feel, yes or no? This used to happen with me every marriages I used to go. Okay, like I used to go to marriages just for eating food. Okay, every marriages in our village, it was custom, it was my custom duty, it was my mandatory duty to attend just for eating good foods, right or not? Okay, so I used to go. First I'll eat, means those what we say, uh, what comes like initially before the food and all. We have some special name for that. Okay, so I have forgotten that. Of course, yes. So something like brief course or something like that, it is called as a. Okay, means so introductory foods, you can say. I used to first finish that golgappe, chowmein and all. Then after that, finishing it, my stomach is full. Then I used to think, okay, I have to still eat the foods. Let's go to bathroom once. Okay. Then I'll go for bathroom once. Okay. After eating that food, okay, half an hour later, after walking here and there, and that's why I used to go to marriages at direct 6 p.m. Okay. When the first starting stall will be started, I will be the first person to eat over there. Right or not? I'll first finish that coffee and all those things. Then it's the bathroom time. I'll go for bathroom again. All the digestion has been already completed. I'll finish that. Then again I'll return back to the food stalls. Right or not? So after that, I'll eat the food items. The next day, okay. Next day means it used to take 2 to 3 days to digest all the process of this thing. Right or not? So this is what it is. Okay. Yeah. Look over here. So what is happening? If this if this particular bar magnet is coming over here, it is generating north pole. Now when it has generated north pole, what will happen? This bar magnet will come over here. What is the property of this loop is that now it will not, now it is not going to make this bar magnet go outside of it, right or not? What is the property of this bar magnet? That it will not try to let this bar magnet go outside of this magnetic loop, right or not? Now to make this happen, see, if this is my south pole or not, this is my south pole or not. If I can make over here again a north pole, then what it will do? It will attract the south pole, right or not? It will not let the bar magnet go. So again it's generate what kind of pole? A north pole over here, which makes the current rotate over here anti-clockwise. Is I'm correct or not? Is this correct? Okay or not? So that means what? It will always oppose any kind of change in its system. Remember that. So now look over here. When this particular current loop, when this closed loop is getting pulled inside the outside magnetic field, what is going to happen? Flux is increasing or not? Or yes or no? But actually what should be the property of this closed loop? That flux should not increase. What should be the property of closed loop? Flux should not increase. Now flux should not increase. How? Area is going to change, but if it can cancel the magnetic field, listen me, if it can cancel the magnetic field, then the flux will not change or not? Tell me yes or no. Why? Because the total magnetic field of the particular in that region will be how much? Zero. Right or not? So is this magnetic field is upside or not? What is the direction of this magnetic field? Upside. Got it or not? If I can produce a inside magnetic field, what will happen? The total magnetic field in that region will become zero, and the flux through the system will become how much? Zero. Now if it is an inside magnetic field, place your thumb inside, yes or no? When you will rotate, how it is rotating? Anti-clock, sorry, clockwise. If it is inside, how it is rotating? Clockwise, yes or no? This is clockwise direction. If it is outside, how it is rotating? Anti-clockwise. Got it or not? Is I'm correct or not? So therefore, if it is entering inside, since it is generating what kind of magnetic field? inside the magnetic field. Therefore, the current produced is what? In this particular loop, it is in the which direction? Clockwise direction. Got it or not? So flux is increasing. It generates. Hey, Chandra. Worry. Hey, leave it. Hey, you know, today only. Hey, yes. Where is my party? I completed 1 year over here. Got it. Okay. Hey guys, now look over here. Second case. Hey, Chandra. Do the question. See the second case. Second case is what is happening. Now loop is getting pulled out of the magnetic field. Loop is getting pulled out the magnetic field. Area of loop inside the field decreases and the flux passing through it also decreases. But look at the magnetic field. This is which kind of magnetic field? Inside magnetic field. Got it or not? Are you yes or no? What kind of magnetic field it is? Inside magnetic field. Now, when the particular loop is getting pulled out of the magnetic field, what is happening? What is happening over here? There. If it is getting pulled out of the magnetic field, what is happening? Its flux is getting decreased or not? Its flux is getting decreased or not? So what should be the condition of loop? That flux should not decrease. Right or not? How the flux will not decrease? See, inside magnetic field is there. If it generates outside magnetic field, then the total magnetic field will be how much? Zero. But that condition is what? It is a condition already for flux decreasing, right or not? It wants its flux to be increased. So it will generate the similar magnetic field to make the magnetic field attract or not. Tell me yes or no? Or yes or no? So it will also generate the magnetic field inside, which is going to make the current rotate in clockwise direction. Got it or not? Yes or no? If it is going inside it, what was happening? Flux was increasing, so it generates the magnetic field opposite of the magnetic field which was present over there. So you can observe. So I can write like this way. Okay, 1 minute. Flux increases. Okay, generates current in the direction in such a way to oppose ma- the magnetic field present already. Hey, okay. Flux decreases, generates current in the direction in such a way to attract the magnetic field present already. So in this you can write like magnetic field generated is opposite of magnetic field present This is good now. Magnetic field generated is in similar direction of magnetic field present. Right or not? So what it is saying that if your flux is increasing, you have to generate the magnetic field so as to oppose the magnetic field which is present already. Right or not? That means what? Magnetic field generated should be always opposite to the magnetic field present. If the flux decreases, what should happen? Actually, attraction should happen between the two magnetic fields, generated magnetic field and the present magnetic field. So actually, if the flux decreases, you should generate the magnetic field in the similar direction of the present magnetic field. Got it or not? Or yes or no? Read this fast. So now look over here. This question, particularly this question. What is happening in this particular question? The particular circular coil was getting compressed or not? Tell me yes or no. Or yes or no? If it is getting compressed, is the flux is decreasing or not? So look over it. Phi initial was some kind of positive value. Phi final is what? 0. So what is happening? Flux is increasing or decreasing? Flux is increasing or decreasing? Is it increasing? Initial flux is what? Some kind of positive value. Final flux is what? 0. So flux is what? Increasing or decreasing? Huh? Decreasing. So if flux decreases, therefore magnetic field will be produced in the similar direction of the present magnetic field. Got it or not? Or yes or no? So inside this loop, magnetic field is inside. Also, you should produce a magnetic field which will go inside or not. Tell me yes or no. Put your thumb inside. How the current will be produced? Clockwise direction. So how the current is getting produced in this? Clockwise. Got it or not? Or yes or no? Is it clear? Okay. So what is the direction of current? It will be from A to B. It will be from A to B. Got it or not? Okay. Now, did you have written this point? Okay. Moving to next point. Point number third. Now what is saying? Like, okay. First try to write that. Let us have some kind of loop. You have some kind of loop over here, current carrying loop. Got it or not? Okay. Now we have it can be any kind of closed loop. Got it or not? Of arbitrary shape you can consider like this kind of shape also, symmetrical shape also. Now what it is happening? Let's suppose you have placed this particular loop near the current carrying wire. What is there? You have some kind of infinite length current carrying wire, and near that current carrying wire you have placed this loop. Got it or not? Now look over here. As you know that for any kind of current carrying wire, what was the formula? What was the formula? B is equal to mu naught I by 4 pi into distance or radius r or distance d, perpendicular distance d. Got it or not? You learn like this way: r perpendicular, not the distance. Okay, learn like d perpendicular or r perpendicular. Got it or not? Okay, into sine theta 1 plus sine theta 2. Got it or not? Yes or no? Okay, so can you do one question based upon this? Look over here to make you revise one thing. This is my wire infinitely. Okay, it is going till infinite. Got it or not? 1 minute. Okay, so now look over here. It is saying that let us consider a point over here which is located over here. Okay, I join the one end of this point. I join the, sorry, it is not infinite, it is a finite length wire. Got it or not? One point is, I join both of the points. What it is saying that let's suppose this length is 5. How much is this length? 5. This angle is 37. This angle is 53. Got it or not? What is given? That angle is 37, this angle is 53. Got it or not? You have to calculate the magnetic field generated at point P. Got it or not? Let's suppose this is my point P. Calculate the magnetic field generated over here. Do it fast. Do it fast. Do it. This length is 5 meter. Let us consider A, B. AB is given. AP is given, sorry, which is equal to 5 meter. So what is the formula of magnetic field to a straight conducting wire? B is equal to mu naught I by 4 pi D perpendicular into sine theta 1 plus sine theta 2. You guys are not remembering any kind of formula here. Where is the stick? Where is comfort? Do it. Do it. Do this question fast. Okay, first tell me, Rakshita, theta 1 is positive or negative? Theta 1 is positive. Theta 2 is positive or negative? Mm-hmm. Tell me fast. Harshita, both of the thetas are positive, na? Yes or no? Shreya, both of the thetas are positive or not? HM, both of the thetas? Both of the thetas are positive. Huh? Already I have done this question for you guys. Already I have done this question for you guys. Harshita, now tell. Positive or negative? Huh? Negative. Yes or no? Both are negative or both are positive? Or both are, one is negative, one is positive. Uh-huh. One is negative, one and positive. Why? So look over here. If you consider for a straight wire, this particular formula, this particular, let's suppose you have a finite straight wire. Okay. If you are required to calculate at this particular point some kind of magnetic field, what you need to first of all select the perpendicular length. Yes or no? Joining the P to the wire. Got it or not? So first of all, we considered perpendicular length. Let us call this as R. Right or not? After that, theta 1 was considered upside in the derivation and theta 2 was considered downside or not? Tell me yes or no. So here theta 1 is upside. Let us consider 53 degree as theta 1. So theta 1 is positive. But theta 2 is, according to convention, it is upside or not? Tell me yes or no. So this will become negative or not? This will become negative or not? So theta 2 is actually, you have to consider minus 37 degree, theta 1 to be equal to 53 degree. Trick is what? Right angle triangle 3, 4, 5. This is what? 37. This is what? 53. Right or not? You'll remember this trick always. Yes or no? Now, here another last thing is what? You have to consider R perpendicular. This should be our D perpendicular, which should be considered. So should I take 5 meter? Should I take 5 meter? No, now it is asking for them this particular straight wire. You have to calculate the magnetic field at point P. So first of all, you will draw one line. Yes or no? Now on that particular straight line, draw one perpendicular line joining point P. Wide or not? If this is 5, this is, let's suppose, 37 degree. So is this is going to be 5 cos 37? Or yes or no? It's going to be 5 cos 37 or not? Is it okay? Is it okay? Wake up, Chandru. You are waking up, Chandru. Studying Hindi, Chandru. Is it okay? Now move to the next point. So here, it is an infinite state wire or not? Or yes or no? Dhanush. If it is infinite state wire, theta 1 and theta 2 are what? In this question, theta 1 and theta 2 will become what? If this is an infinite state wire? Ah, theta 1 will be positive. I want a value of it. Theta 1 and theta 2 will be what? 90 and 90. Right or not? Theta 1 will be equal to theta 2. That is going to be how much? 90 degree. So therefore, what is going to be magnetic field? Mu naught I by 2 pi x or not? This x is what? Actually, it is. You can call it as r, which is r perpendicular. Right or not? Yes or no? So that means what? If you have any kind of a straight current carrying conductor, the magnetic field is directly proportional to the current in it. Yes or no? Or yes or no? So for this, let's suppose how the magnetic field will be generated, like this way. Yes or no? So this magnetic field is going to be what? Perpendicular to this amount of current which is over here. Yes or no? Now, for this particular current loop, what is going to happen? For this particular square loop over here, this magnetic field will pass through it and it will generate some flux over here or not? Tell me yes or no? Or yes or no? Yes. Now, flux has formula what? B dot dA cos theta or something like that. Hey, look over here first. Look over here. So flux is equal to what? B dot dA. Here, look over here. When the particular current is passed through it, area is not changing. Yes or no? Because the magnetic loop, this particular current loop is not getting moved. If the current loop is not getting moved, area is not changing. To produce the flux should depend upon what? It should depend directly on the magnetic field or not. Tell me yes or no? Now, this magnetic field depends upon this current I. Got it or not? Is it clear or not? Or yes or no? So now look over here, try to understand that. Please try to understand what will happen if this loop is moved, or what will happen if this current is changed with respect to time. Tell me that. What will happen if this current loop is moved, or what will happen if the current in that straight wire is changed with respect to time. So now, first important thing, look over here. If di by dt, which is change current in the straight wire with respect to time, this change is positive. What kind of change? Positive. So magnetic field will increase or not? Or yes or no? Flux is going to get what? Increased over there. Got or not? If this di by dt is what? Negative, what will happen? Flux will decrease. So what will happen? Again, now, this first important thing, if the flux is positive, so what will happen with the loop? It will not let the flux get increased or not. Tell me yes or no? Or yes or no? So if the flux is not getting, if it wants that flux should not increase, that means what? It should produce the magnetic field in the opposite direction or not? Tell me yes or no? First of all, look over here. If this current is going up, magnetic field is going inside in the loop, in the particular current, in this square loop, right or not? So if di by dt is positive, where it should generate the magnetic field? It should generate the magnetic field actually outside. If the magnetic field is outside, it will oppose the magnetic field inside and the flux will not increase in it. Got it or not? Are yes or no? Now if the magnetic field is outside, how the current will be generated? Anti-clockwise or not? So look over here. How the current is getting generated? Anti-clockwise. Got it or not? Do it. Write it fast. Chandro, Baba Chandro. He will be parents next week. I thought he is going to become parents next week. He is even faster than Ranbir and Alia, huh? Okay. Talk to her parents. Chandra. Do not run behind girls. She will destroy you, word or not. Girls are destroyer of life. Okay, they will use you and throw you in the dustbin like anything. Got it? Yes or no? No, sir. Got it or not, Chandru? Is I'm correct? Is this okay or not? Now look over here. Now, one thing you try to say, I have written di by dt and I have written di by dt. Got it or not? Di by dt means what? Change of current with respect to time continuously. In what way? Continuous way. Means for every small second the current should change. Got it or not? Means for even 0.01 second some value of current should increase. For 0.02 seconds some value of current should increase. Then only this kind of case will be possible. If it will be finite change like phi 2 minus phi, I2 minus I1, then this kind of current will be never produced over there. Right or not? Is I'm correct or not? Because finite changes is not going to bring anything. EMF is what? Minus of d phi by dt. Means what? What kind of change? Continuous change. Right or not? Are is it clear or not? Now, second important point. Look over here. If you got to know for what will happen if the current change is positive, what will happen if the current change is negative? Magnetic field through it, what it will decrease or not? Now, if magnetic field decreases, what will decrease? Flux will decrease. So, is this loop is not what this loop will try? That flux should not decrease or not? Tell me yes or no. Yes or no? What will be the property of the loop? That it will try that the flux should not decrease through its system. If it should not decrease, then it should generate some kind of magnetic field in the similar direction of the magnetic field or not. Then what kind of current will be generated in negative change? The magnetic field will be generated in the magnetic field will be inside and the current will be generated how? Clockwise. Right or not? Is that clear or not? So first two cases of current change has been done, right or not? In this magnetic field, see current was anti-clockwise, and here current is actually clockwise, right or not? Hey, look over here. Point number 4. What is happening? If this conducting loop is brought away from the current carrying straight wire, as the loop is moving away, now what we are doing? Now we are changing. See, can I erase this? Should I erase this? Should I erase this thing or not? Okay. Sorry, guys. Now look over here. What we are doing? Hey, this conducting loop is now getting away from the particular magnetic field, right or not? Okay, means we are trying to put. Hello, प्रणाम बाबा. ठीक हो बाबा, क्लास लेते हैं थोड़ा कुछ काम होगा. Tell me, what is happening over here? That particularly this particular conducting loop is getting away from the particular current carrying wire. Now, for this current carrying a wire, what kind of magnetic field it is generating like this? Right or not? If this loop is getting moved away, what will happen? Flux will start decreasing or not? Or flux will start decreasing or not? Now, magnetic field is inside for the plane of the loop, yes or no? B is inside over here, right or not? According to this particular wire. Got it? Now, if this loop is moved away, what will happen? Flux will decrease. If flux is decreasing, so what should be the condition of Lenz law over here? It should generate some kind of magnetic field which should attract this magnetic field or not. Tell me yes or no. If this particular loop needs to generate some kind of magnetic field which will attract this magnetic field, that means what? For the loop, again the generated magnetic field will be towards this side or not? Tell me yes or no. Or yes or no. Now, if this magnetic field generated is inside, so that means what? Current developed will be in what way? Clockwise way or not? Tell me yes or no. So how is the current going to get developed in this wire? Now, current is going to get developed clockwise, right or not? If the particular this particular loop is brought nearer, what will happen? Magnetic field flux will increase. If the flux is increased, magnetic field will be again generated. Should be what? It should be generated outside, so as to oppose the inside magnetic field, right or not? In that case, again it will be generated in what way? Anti-clockwise direction. So whenever it is, if the flux is increasing, magnetic field should be opposing to each other. Generated magnetic field and the present magnetic field should be equally opposite. Second thing, if the flux is decreasing, both of them generated magnetic field and the present magnetic field should be in the same direction. Is that clear or not? Write this. Write this. Draw that diagram and write this. You know why I put this? I thought that it will go and bring that feeling out. To bring it out. What do you buy that? Means that phone is not in my interest only. I have seen now. Like this is only costed 35. Other more invested 15 years ago. I bought a phone. But not even myself. Motorola I needed to last 2015 I got my first phone. From 2015 till now I am using just Motorola. I can't use another phone. Actually, I am addicted to Motorola company. And thanks to Motorola company to bring a good phone. If they even bring bad phones also, I'll have to buy that Motorola. Means it's that addiction of Motorola. Is it okay? Yes. Whatever it is. Can I move ahead? Yes, sir. Okay. Now, hey, what happened? Okay. Now, fifth case is a kind of example. Let's suppose if you have a particular inside magnetic field, word or not? What kind of magnetic field it is? Inside magnetic field. And you have two loops over here. One bigger loop, another a smaller loop. Word or not? Now, the question is, if the present magnetic field increases, then what should happen? Okay, what we are doing? This inside magnetic field which is present over here, void or not? This inside magnetic field which is present over here, we are increasing that, void or not? Yes or no? What we are doing? We are increasing that. The question is, in what direction, in what way the current will be developed in this loop? Tell me. But there are two loops actually. Clockwise or anti-clockwise? Okay, listen me perfectly. Magnetic field is increased inside or not? That means what? Flux will be increasing? Or yes or no? So the generated, so if the flux increases, according to Len's law, the body will try that flux should not increase, yes or no? Which one is a bigger body? First one. So first one will be responsible for much more repulsion of the particular magnetic field which is getting increased over there or not. Tell me yes or no? Yes or no? So now look over here. What will happen for the first body? If the magnetic field is increases, flux will increase, and the body will try to have the magnetic field which is going to oppose that present magnetic field or not. Tell me yes or no? So that means what? This bigger body should generate some kind of magnetic field which is present outside. Yes or no? If it is outside, it will oppose this inside magnetic field. Got it or not? Or yes or no? If it is getting, if the magnetic field is outside, in what way the current will be produced in the bigger body? In anti-clockwise direction. Yes or no? Or yes or no? Magnetic field is outside, current is anti-clockwise. Magnetic field is inside, current is clockwise. Got it or not? So, how the current is generated in this bigger magnetic, in the bigger loop? In the anti-clockwise direction, while similar current will go in this second loop, but it will become what? Clockwise. So now look over here, second loop, due to this kind of way, second loop is actually increasing this magnetic field again, but the first loop is actually opposing the magnetic field. Got it or not? Is this clear or not? So if magnetic field increases, what will happen in the bigger loop? Remember that in the bigger loop, the current will be generated in such a way to oppose the present magnetic field. In bigger loop, remember that whenever there is an intersection of two loops, three loops, concentric rings, so in bigger loop, the current will be generated like that way. Right or not? Is it okay or not? Chandra Baba Chandra. Yan Chandra. Yan Lasha. In farewell, we'll make him dance. Go ahead or not? Okay. December 17th. Let's come. Make a combined performance. Good or not? Second PUC, no one will do anything. Ah, ah, no one. If anyone goes in that function, I'll break their legs. From these five guys, no one. That's good. That's great. Really. Hmm. Hmm. Previous year annual day was not there, no? Can you move ahead? Okay. So these are not the eyes of Sundar Kanya HM, right or not? Okay. Do not get flattered on that. Okay. Can I move ahead? Okay. Now look over here. What is happening? Hey, listen. Let's suppose if you have again this kind of bar magnet over here, right or not? Now, I already told every time that day when I was showing you that this clockwise rotation or anti-clockwise rotation depends upon observer or not. That white page I have shown now. You were saying that I was saying just opposite of that, right or not? You were saying anti-clockwise, I was saying clockwise, and this is also applied over here. So let's suppose if your observer is towards this side, right or not? If your observer is towards this side and the particular object is coming towards this side, so this is what north pole, this is what south pole, flux is going to get increased, yes or no? It should generate a particular field, or it should generate a particular current in such a way that it should oppose this particular flux increase or not. Tell me yes or no. How it's generated? It's generated in north direction. If it is in north direction, how will be the current generated in it? Clockwise way, sorry, anti-clockwise way, or yes or no? For the observer which is kept over here, but if the observer is towards this side, is it going to be clockwise or not? Tell me yes or north pole, anti-clockwise, yes or no? Or yes or no? Yes or no? 100%. 100% or not? Change the observer, change the direction of current. Right or not? Is it okay or not? Sagalaga. Okay. So when the north pole moves towards the ring, that is what it is written. Then the flux will increase, induced current will oppose this. So north pole will be formed on the loop as seen by observer. Right or not? Second case, when the north pole moves away from the ring, what will happen? Flux will start decreasing or not? Or yes or no? So magnetic field should be produced in similar direction, right or not? So to attract it, how it will attract? Opposite pairs attract, like Chandru and Pari will attract, right or not? So how which pole will be produced over here? South pole will be produced over here, right or not? So as to attract this north pole. Is I am okay? Yes or no? See, HM only started this, right or not? If tell HM, right or not? So therefore, if south pole is there, which kind of current will be generated? Clockwise. But if the observer is towards this side, what kind of current will be generated? Anti-clockwise. Right or not? Now, just the opposite case, if this is south pole, which pole will be generated if the motion is towards the ring? South pole will be generated, yes or no? And the current will change to clockwise, right or not? For the here observer, it will be seen as anti-clockwise. If it is moved away, which kind of pole will be generated? North pole will be generated, and which kind of rotation of the current will be there? Anti-clockwise rotation as seen by the observer. Is it okay or not? Write the first, second case, means write only sixth case. Do not need to write C and D part, right or not? Just write A and B. C and D, it's visible. Yes or no? You have already done that. Is this okay? Tomorrow we are going to do some problems related to based upon this. Okay. But one question we need to do right now. Can I move ahead? Can you write? It is given in DC Pandey. Okay. You follow DC Pandey, it will be for NEET. That's the best book. DC Pandey, just two volumes, NEET 1 and NEET 2. The questions are never going to come out of that. Okay. Better is HCVAMA. Complete HCVAMA, less number of questions, less practice time, more knowledge. Right or not? Do a smart work. People who solve HCVAMA, they always tell they are much more smart enough. Right or not? Can I move ahead? Tell me. Okay, now write the question. Okay. You have two circular coils, correct or not? Like Helmholtz, I have done the calculation of Helmholtz coil or not? Tell me yes or no. So you have two perfect circular coils, right or not? Okay. Now, they are two axial circular loops. Mention that they are two axial circular loops identical to each other, and they carry equal current. Okay. So they have similar current in the similar direction of rotations, right or not? Hey. Now, question is, if these coils are brought towards each other, brought towards each other. What is happening, guys? The coils are getting brought towards each other. Then what will happen? You have to tell me. If the coils are brought towards each other, then what will happen? You have to tell me. First, magnetic field is generated opposite. Hey, listen. B. B is generated in similar direction. C. Current increases. D. Current decreases. Hey, tell me, what will be the answer? Okay, for a ring, for this ring, can we calculate this magnetic field over here? Let us consider that this is at distance x, and the radius of the rings are what? Capital R. Right or not? What is the magnetic field at the center of the ring? Mu naught I divided by 2 R square divided by x square plus R square to the power of 3 by 2. This is the formula. Or yes or no? If this particular current carrying rings have n loops, so it will be multiplied by n. Right or not? So now look over here. What is happening? You are bringing these loops towards each other. Yes or no? If I am bringing this loop towards each other, what is decreasing? X is decreasing or not? If X decreases, what should increase? Magnetic field should increase. If magnetic field at the center of these rings, both of these rings, see, this ring will also have the same magnetic field at this center or not? Tell me yes or no. So is the magnetic field at both of the rings are increasing? Or yes or no? If magnetic field increases, what will increase? Flux through both of these rings will increase or not? So what is happening? Flux is increasing. Now, if flux is increasing, they should have opposite magnetic field generation or not. So now look over here. This magnetic field is, let us consider that for this particular thing, magnetic field is towards this side. So for this particular current, the loop, the means in this loop, the current should be developed in such a way to oppose this magnetic field or not. Tell me yes or no? Or yes or no? Now, this current is rotating in which direction? Anti-clockwise direction. So it should produce some kind of current I prime in the clockwise direction so as to oppose this current I. Yes or no? Or yes or no? And in similar thing it will happen over here also. What will happen? Current I prime will be developed over here. Right or not? So that means what? Total current in this particular loops are decreasing or not? Or yes or no? What is happening to the total net current? It is decreasing. So current decreases in this Helmholtz coil. Right or not? If the coils are brought together, what happens? Current decreases, not increases, not decrease. The flux B is generated of opposite direction. That is nothing like that. Okay. So current decreases. And B is generated in the opposite direction. A and D. You have to consider B prime, not B. B prime you have to consider. Okay. Is I'm clear? Okay or not? Okay, so we'll finish this tomorrow. or in the evening we have to do this motional EMF. Already we have done the concept of motional EMF.